Welcome everyone. Today we have our another new episode, and this episode definitely will be very important for us. We will discuss on edge computing. We have our world famous speaker, Professor Edward, Smith, Professor Ching, Mr. Marshall, Professor Rob. We have a very good news that we are launching Nikola Tesla Technology Conference. If you go to our website, with your permission, actually, we are promoting all of our speakers in our website, especially the local media from different countries like India, Bangladesh, Pakistan, Malaysia, Singapore. They are really, really happy to attend in this Nikola Tesla Technology Conference, and I'm sure, and it will be hybrid. It's not mandatory you have to visit India, so you can join like this way. So hopefully this like Nikola Tesla Technology Conference will be very, very helpful for Asian people. So we will discuss on edge computing. First, I want to give chance Professor Edward.
Yeah, well, thanks a lot for this interesting show. Pardon my voice, I'm still getting over a cold here. Edge computing, the best way to think about it is really simply decentralized data processing. In other words, let's imagine a company, and you can have data coming in about your sales, about your supplies, and all of this kind of stuff from all over the world, all over the country, into one place where it's processed. Or you can say, maybe we can actually, number one, save some time, some money, and get really what we want, the summary from, let the satellites, so to speak, do the data processing themselves, and then give us the summary. Or if you're a government agency, let's say, okay, and you have an issue about looking at traffic patterns and how they're changing in a region over time, and how it interconnects with the whole transportation system within a country. Well, maybe instead of having a big central office that does takes all the data to put it all together, you say, okay, you over here, you figure out this and give us the summary. Give us the statistics that we really want to know, okay? And so we don't have to sift all through it. It's really sort of decentralized data processing is another way to think about it. We talk about in manufacturing just-in-time inventory, right? Meaning that instead of having warehouses full of stuff, you try to get the inventory in there as quickly as, as timely as possible when you need it, and then you use it in, your manufacturing process. And you might want to think this is like just-in-time data summaries. I want to make two other kind of connecting points here. First of all, good companies all usually do that sort of thing. In other words, a good executive, I don't claim to be one myself, by the way, so please don't use me as an example, will basically say, well, you look at this particular issue. We want to know whether we can take and use this technology to make this particular thing that's going to go into the next iPhone. And team, you guys figure it out, give us the summary, and then we'll go from there. Instead of, doing, you have little teams that are basically coming up with the stuff. So in a sense, when you talk about edge computing, you're kind of talking about what goes on in the company right now anyway, or at least the companies that tend to be very successful and cut out a lot of bureaucracy, that sort of thing. I want to mention one other thing. One of my favorite economic thinkers, he won the Nobel Prize for Economics, I think it was 1973, F.A. Hyde, Friedrich Hyde. He came up with a economic concept of spontaneous order, spontaneous organization. One of his great insights was that knowledge is usually best understood decentralized. The simplest answer, or simplest example, is that you're in Kuala Lumpur, Washington, D.C., wherever it is, and you want to run a restaurant, a chain of restaurants, you probably have better data and information locally than, say, the central office in wherever it is to be. If you look at the restaurant chain, you have better data and information on customer preferences, things like that. As long as you have a free market and liberty, then prices give you data, gives you information, right, about demand, supply, what you need more, what you need less, and so forth. Now this is one of Hayek's great insights about information, the importance of information. And again, it's the entrepreneur who's at liberty to take that information that they know uniquely and use it to produce value, goods, and services. So in a sense, when I look at edge computing, I think, well, this is just kind of a different version of F.A. Hayek's insights about information and how information works within the economy and how good entrepreneurs, use information in a very efficient way. So with computing, it's instead of having all of this stuff coming into my central office and we got to process it, you say, guys, you over here figure this thing out. Within a company, it's okay, we're going to have little teams. You figure this part out for the iPhone, you figure this part out over here. And in the market, you have the same sort of thing. So that's kind of my insight, that edge computing is simply another version of this notion of decentralized information that entrepreneurs can use.
Thank you, Professor Edward. I know I think you need more rest, and I'm happy that you also join in our forum. I can understand how passionate you are about our forum and our open dialogue. So thank you, even in this condition, you join with us and support our initiative. We have Professor David Smith. What you want to add for today's session?
I love this topic. It's one I'm actually very, very passionate about. And Ed, I have to give you a doctor's prescription. Go eat fresh jalapenos with the seeds. It will, highest source of natural vitamin C, natural decongestant in it. It will take care of it.
Yes. Okay. And my tongue will never forgive me.
Oh, but it will fix your voice. So really, let me go back a little bit further back on edge computing. Edge computing, its key premise is that it acts on data at the source. And that is really important with where our world is going. So edge computing is a distributed computing framework that brings the applications closer to the data sources, and particularly with devices such as Internet of Things devices, really the explosive growth of medical devices that are available to the consumer, and other devices that are designed to work in real time. And the edge computing really is the business benefit is that close to the source brings you faster insights, improved response time, better bandwidth availability, and particularly as you begin to look at some of the sensors and other elements like that, it's very important to be close to the sensors. The Internet of Things sensors are designed to be very low power. They're really designed to have a really low latency, which means that it has to be done at the edge of the cloud. The other thing that is, you're beginning to look at this, Gartner, and even though Gartner's good, I'm not a fan of them, but Gartner estimates that by 2025, 75% of the data will be processed outside the traditional data center or the traditional cloud. And what that means is you're seeing this very big movement, 75% of data to the edge of cloud. And that is a trend that's going to affect all of us in different ways and different ways to handle it. The market size of edge of cloud is growing. So in 2020, it was about $4.68 billion. And it's growing at a compound annual growth rate of almost 39%. And so you're seeing it's going to be getting quite large as you begin to get there. And the edge computing market is really made up of the edge managed platforms, services, software, and even hardware that is optimized to be able to be used at the edge of cloud. I can tell you, I was at a couple of different conferences this week, and part of it I was there wearing my marketing hat as a chief technology officer. And we sell a platform in healthcare that has the ability to federate to edge of cloud devices, to edge of cloud micro databases and containers and stuff. And we had people coming up and asking us, how do I get to the edge of the cloud? And it's one of the few times where I've ever seen people come and say, I want your product, before you even tell them what your product is. And to me, that underscores really where edge of cloud's going and its importance. We're even seeing edge of cloud deployed in space. NASA has launched an optical network into space that's designed to push their space internet to the edge of cloud, and including an intergalactic edge of cloud now. So again, I'm excited about where this is headed. I could talk, Sharif, about edge computing for your entire program and probably not repeat much. But let me just introduce from here, and I'll sit back and listen and throw in some stuff further towards the end.
Thank you, Professor David Smith. Professor Kim, what you want to add for today's discussion?
One of my favorite discussions, Internet of Things. How far have we come along in the past few years? Have we met our predictions? Are we keeping it safe and secure? What do they do with the data? And I remember these conversations back in 2014, I think it was, and I attended a conference, and they had a gathering of minds of AT&T, Sprint, most of the executives, and this is what they were talking about, is all the smart devices that they were coming out with, and that's when the phablet came out, where it was, I think, right after that. They collect data everywhere, and this is what I try to tell people: don't worry about your privacy anymore. Even back then, they were predicting that as you go into a grocery store, your smartphone is going to know precisely where you are in the grocery store, and it's going to be printing out coupons for you as you're looking at the can of soup. It's going to print out a can of soup. So, everything about the data that they're collecting, data is gold. They have been saying this for years. Data is the gold. It's not the money that's being spent today. It's the data they collect about you that's the most valuable asset. Internet of Things, over 2 billion devices, 10 billion devices last year. Predicting, trillions by 2025. Where are all these devices? Well, let me tell you. If you go and participate with smart cities, they're actually on the edge of a light bulb that goes into your refrigerator. They're actually in the seat of your car, of a smart car. Most Priuses have a device that measures you and weighs you every time you get into your driver's seat, and it sends data out to the cloud. You actually agreed for this to happen when you buy your vehicles. So be careful out there of what you agree to, and make sure that you go back and ensure that any contracts that you sign don't allow third-party access. But Internet of Things, it's intended to also do a lot of good. Take care of you. Like recently, I became sick and was able to go online, visit my doctor online. I was traveling, and he quickly prescribed me what I needed without me having to go to a medical center or visit a doctor I don't know. And it just instantly, boom, here's your medication. They can view you, that you upload pictures. Eventually, you could do a scan of your temperature. They'll be able to send test kits out to you. So there's just so many things that are happening, and every day the evolution just gets bigger and bigger. And the question is where do we go from here? And what also kind of like what my biggest concern is with information, what information is safe, right? What information is correct and accurate? Because the data we collect and how it's processed is still created by humans. So our artificial intelligence and all the data and information that we're processing can still be at error because it's all still processed by HI, which is human intelligence. But I'm thrilled with where computing and science has come and where we're going, and I look forward to seeing where it goes in the next 10 years.
Thank you, Professor Kim. Professor Rob, what the interesting thing you want to add? Because recently I believe you visit many corporations. So for edge computing, what you want to add, Professor Rob?
Well, simply speaking, edge computing is part of the cycle that we've had since the beginning of computing, of either centralizing or decentralizing the processing power in order to optimize the whole. So you've got several components that go into computing. Is my camera frozen? Looks like my camera's frozen.
Yes.
But you can hear me. I'll change cameras in a minute. So you have a system. The system consists of processing power, some type of network, whatever is capturing the information to begin with, and then you've got to optimize that system. And we started off with highly centralized systems, mainframes. And then at the edges we had, well, initially we didn't have anything at the edges. We just put in cards and hope they came up with the right answer. But eventually we moved to terminals, which kept the processing power centralized. And then Sun and their infinite brilliance came up with the concept of client-server computing, which fundamentally didn't work when they brought it up. In fact, it came out in the mid-'80s. It was about the mid-'90s we finally figured out that none of that stuff was working. Good concept, but it wasn't doing what folks were saying it was doing. But we still started a shift, and that shift moved us to PCs. So an awful lot of the stuff that was done centrally began to be done on personal computers that people had at their desks. I remember at the time when this came about, because I was having a great deal of trouble getting stuff through what was then MIS, now called IT. Management Information Systems was what MIS stood for. And so finally I would be able to do stuff on my desk. And so we were able to run first Lotus 1, 2, 3, and then a variety of other programs, including the Condor desktop database program, which I still remember fondly today. And that allowed me to sidestep IT, and then we moved to a much more decentralized model with regard to computing. But that introduced a series of problems with regard to economies of scale, security, and the fact we really didn't have a network back then. We were moving stuff around with something we called SneakerNet, which was anything but secure and anything but quick. And then of course we moved to advanced networking with technologies like Token Ring and then Ethernet. I still remember getting in arguments with Siemens over whether ISDN was going to be the future or not. It was going to be Ethernet, so in the end, we had the network, and we finally had what you could call client-server computing, where some of the processing was going on the desk, and some of the processing was going on centrally on servers. The next wave really was to move to the cloud. This idea of, again, we have a lot of processing power that's centralized, relatively, at least initially, on intelligent devices in terms of smartphones, and not a lot of shared processing power going on between the PCs and the cloud services that were being provided to them. And then once again, we ran into network problems. The network was not adequate to handle the load, and so a lot of what was a shift back to centralized computing didn't work. The underlying concept was thin client computing, and Sun and Oracle both promoted this idea of being able to do it all centrally again, have the economies of scale of those centralized processors. And their big failure was the fact you have to understand what you're going to replace in order to replace it. And they didn't understand how PCs worked at all. The Sun went a little farther with Sunray 1, which was in many ways better than PCs. One of the ways it was better was you had a persistent presence. You could be doing a job at work, leave work, go home, log into the service, and you were exactly where you had left off at work, which I thought was pretty handy. And they also did something that IBM said should have been done in the 1980s, which is move away from passwords and IDs, which when we did the study said we're absolutely unsecure and we should never do this again. And that was back in the 80s. And we're just now kind of getting our heads around getting rid of the damn things. But Sun with the Sunray 1 used a smart card, and that's how you would log in. And so you take your card. It was a brilliant demo. You would take your card when you left your terminal, go to another terminal, plug in the card, and presto changeo, your desktop was there, and you could work. And it was much more secure, but it wasn't particularly capable. And the overall drag on productivity that platform had was part of the reason that Sun Microsystems. It wasn't the only reason, but it was part of the reason Sun Microsystems failed. It really slowed down their productivity. The system bogged down, wasn't optimized, and the productivity tools they had wasn't Microsoft Word or Office. It was what Sun had come up with. A similar mistake to what, by the way, Oracle did a few years earlier when they came out with their own competitor to Microsoft Office. It was it was bad, and they made everybody go on it, and that damaged Oracle's productivity. It kind of goes to the point sometimes when you're looking at a tech company. There's good and bad to having them eat their own dog food. When they do it and they're successful, it showcases the program's work. When they do it because they're stupid and it doesn't work, it has an overarching drag on the company, and that drag can multiply. So anyway, moving to the cloud, which is kind of where we are now. The cloud we're back to network limitations. We only have a certain amount of bandwidth that's available on the network, and that means that as we roll out, as Kim pointed out, this Internet of Things, the difficulty is it's too much data for the network, and so the networks are hitting capacity, and in a way they're throttling because of the over network load. So that means you move processing to the edges again. So some of the processing is done at the edges. That lowers the network traffic and allows you to work much more efficiently than if you were simply doing centralized processing. But we're advancing network capacity, and the network capacity that's on the critical path, that's the path that limits overall advancement, is wireless capacity. And so we moved from 2G to 3G to 4G to 4G LTE. Now 5G is rolling out, which is seen as a huge jump in capacity, approaching wired network speeds, which are also advancing. And then we just began talking about 6G, and the 6G networks look again to be able to solve our network capacity issues with one big major problem. That's the same problem we're having with 5G, which is the backhaul. So when you have a network tower that's up in a city, town, municipality, or whatever, and you've got a bunch of people pounding on that tower, all that data has to go through a pipe at the back end, and that's called the backhaul. And the backhaul can only handle a certain amount of data, and so that once again we're data restricted, which pushes us back to doing computing at the edge computing. And so it is that underlying balance we're trying to manage by shifting processing power from the edge to centrally, and then managing the network capacity issues that happen in between. Now, doing computing at the edge has a number of serious problems. One of them is bias, unintended or intentional bias. And that is because when you do processing at the edge, you're automatically excluding some of the core data that you may later need to make a determination. So the example I have of that was a few years back, Amazon was having a major problem with regard to on-time deliveries, and they're one of the most instrumented companies on the planet. Yet they couldn't figure out where the problem was. All the reports indicated they were delivering everything on time. It turned out that what was happening is that one of their central facilities, their distribution hubs, had decided to help the company out and distribute to end users, to buyers. And because that wasn't policy, the system was set up to exclude any data connected to end user deliveries from the distribution hubs. So when he did that, and pretty sure it was a mail manager, did that, the system couldn't pick up the data anomalies, and he wasn't efficient at it. The hubs just were not set up for user delivery, so it was incredibly inefficient, and it drove up dissatisfaction. But it was because the data had been culled before it had been delivered that Amazon couldn't figure it out. And that's the problem with distributed computing, is that you're effectively culling a lot of the data and sending forward information. But if the data you called was important, you're not going to be able to see that data at the endpoint, and your system's increasingly automated with artificial intelligence. Will be receiving an incomplete picture of the endpoint. I'll give you an example. I'll say, for instance, you've got a security camera, and that security camera has been trained to only report things that look like people. But suddenly you have people showing up in animal masks, and it determines based on those masks and facial recognition that those aren't people, it's something else. So it doesn't send that information in. So the centralized reporting on a security breach does not pick up those people because the camera has determined that the people wearing masks are not people, and so it's not reporting them. And we've had a lot of problems with regard to facial recognition, which is often done in a decentralized fashion. Early on, it was because the test sets only were on old white guys, and so they were really good with old white guys, but really bad with women of color. And in fact, because earlier test sets had used animals, they were equating women of color to apes and monkeys, which was not well received by women of color for very good reasons, and actually did a huge amount of damage to the appearance of and the effectiveness of facial recognition. And one of the reasons why companies like IBM exited the area, even though they fixed the problem, because the press surrounding the activity was so bad and it was brand damaging. So end-to-end information transfer becomes critical. Client server computing was the midpoint. Edge computing is where we really are now, but edge computing still has a major centralized component in the cloud, in which you really have to watch for when you do this balance, is introducing bias and destroying the underlying process, particularly as we move to artificial intelligence, because it will bias the artificial intelligence and lead to bad decisions at machine speeds, which could be hugely damaging. So that's kind of where we are, and that's where I am on edge computing.
Thank you, Professor Rob. I think you are freezing. I think if maybe you have to change your camera or something. We have Mr. Marshall. I want to give special thanks to Mr. Marshall because World Talent Economy Forum, we are doing research on talent economy and human capital. We are publishing our book. Those who interested to contribute in our book with your research chapters and anything you can contribute, Mr. Marshall become champion. He already submit his proposal. Very interesting proposal he submit. I want to give special thanks. So those who from our speakers, from our audience, already we get a very good response from different government agencies, especially from planning ministries, some developing nations prime minister office, especially those who work with talent developments, energy ministries, central bank, Swiss impact investment, some major universities professors, many people from Europe, like especially from Germany, Netherlands, USA, many even Africa, they are actually contributing for our book. Hopefully it will be very interesting, and it will be very much practical, because already we are taking different practical initiative. We're starting our project in Singapore and India and Malaysia, Bangladesh. So hopefully it will be very interesting and life-changing. Mr. Marshall, what you want to add for today's discussion? And thank you for your very good response for our research project.
Well, thank you, Sharif, and thank you for having me on this discussion. I'm at the point, it's interesting, I was involved with edge computing back in 2015 through our marketing research and advertising and marketing company. I attended a function at MIT in which I actually got to see, I'm trying to remember his name, I think it was David something or other, who was a very famous scientist, computing expert, and he kind of articulated what Rob did. And he gave the definition of edge computing, which is that it's not cloud computing. It's definitely real-time information that's sending and transmitting. And I think Rob brought out the big issues having to do with the constraints on it, that if you put filters on it, then you're going to get a lot of different issues that are problematic. I come at this from two sides. One, from having been involved in it early on when it was in the 90s and the early 2000s, right up to the time that I attended that conference at MIT at 2015. And I got more of an input on edge computing. And we used it back in the 90s as an ad agency to get dealer locations for our clients.
and retain that information and using those types of computer systems back then. The internet wasn't in existence, just came about in 93, essentially, from a real-time point of view. We were using these types of computing systems. We were using an email format that was not common to most people. They didn't know about email per se, but that was involved. And then we were getting programs to set up dealer locations for our industrial clients that were setting up dealerships around the nation and around the world. So I'm kind of familiar with it. By the way, Rob, I'm going to make sure that the next time I get on this forum, I'll be wearing my cat mask so that I won't be identified in the world. I recommend everybody else do the same, dog or cat mask. So basically, the term is also used, I think, with another term, and I didn't hear it raised, called fog computing. And fog computing has a sense that, and I think it goes to the point where Rob was talking about it, if I understand it correctly, it creates a fog in a sense. You're not sure what the real data is. It's supposed to stream real-time data. So for instance, today, if you're using information for Internet of Things or industrial Internet of Things, which we're involved in, from a sustainability point of view, I think what you've got is the key issue is, are you getting all the relevant data? You're getting data. The question is, are you getting the relevant data, or are you in the fog? And so I think what needs to be done, and I'll leave it to Rob and to Kim and to David and to all the other players out there who are involved in this, to help create a capability of standards, because these standards are really important now, especially in the area that I'm involved in, which is sustainability and the climate crisis issues. One of the things that we're running up against is we're gathering instantaneous data for our projects that we're implementing, but at the same time, is the data true, and could it cause a problem known as greenwashing, where somebody is intentionally doing something because they've eliminated parts of the data streaming, or they just don't know what they're doing, as Rob pointed out in one case, and we're getting poor data. And that poor data could cause untold harm, especially today in areas where we're trying to turn things around in the developing world as well as the developed world. I've been a proponent of the World Talent Economy Forum to make sure that we meet the 17 Sustainability Development Goals. Those goals are reliant upon not just implementations and deployments, but they're reliant upon making sure that we get the proper data and the information that data turns into information. Information is not data, it comes from data. The information is the interpolation of what the data points are. The question is, are we getting the right data? And I think if we listen to everybody on this panel, we have an opportunity to move this forward. In my realm, on being able to turn both organic and inorganic waste into materials that reduce environmental impacts, the key here is getting the right data. So if we'll give you an example, we're up to 9 joint ventures where we joint venture with people who have waste of all kinds. The only waste we don't deal with is nuclear waste. That's really dangerous. But we do deal with other dangerous waste, such as municipal solid waste, human waste, cow manure, you name it, plant waste. And we convert those wastes into different types of materials that actually allow us to reduce more environmental impacts. If our data sets, which we're getting in an industrial Internet of Things application, are not appropriate or missing data, we are going to be in trouble, and we could be accused of greenwashing. And since our approach is to go through the Climate Bond Initiative to acquire the funds to do this, they have a stringent taxonomy. And that taxonomy says that if you're converting a brown field by European definition into a green field, you need to show that, and you need to show it in as soon as possible, preferably in real time. And that's where edge computing comes in. Edge computing gives us that real-time click, as opposed to the cloud computing, which is also used to gather more information. So I think one of the things, and this is a question for the group, maybe Rob or David or Kim or Hugh or Bob can answer the question: can we use cloud computing in conjunction with edge computing to validate that the data that we're getting is real. How quickly can we do that? Because if you're getting real-time data and you have to make instantaneous decisions based upon real-time data, based on edge computing, and by the way, edge computing is a topology, as I understand it. It's Internet of Things. That's the use case of edge computing. So do we need to adjust the topology so that we can validate in real time the capability? And part of that may have to do with the bandwidth. That would be my thought. Again, this is not my area of expertise. I rely on others such as Rob and David and everyone on this panel to reach out and tell and touch and say, yeah, you need to do X, Y, and Z with our engineers so that we can make it happen. We do have systems. We're using blockchain technology and other technologies out there. We're using Internet of Things technology with what we call pyrolysis, carbon capture and storage systems. And we need to be able to, as we convert that stuff, the waste into materials, we need to know that we're getting the real stuff, that it's not being pilfered. But by the same token, is the data being pilfered? Is the data being corrupted? And in a real-time application, that is really critical, especially today with the climate crisis. Time is of the essence. We need to act quickly for everybody, but we need to get everybody on the same page that when we're looking at this data, we're getting real data and not transposed data or false data or mixed data, as Rob pointed out. So that's my contribution to this conversation as somebody who's using this topology in an industrial Internet of Things to get products out there that will actually reduce the climate crisis.
Thank you, Mr. Marshall, and you will be happy as you are expert of green bond and climate bond. We are bringing a central bank from different countries, developing nations. So I think with our School of Talent Economy, you or anyone want to train our peoples, you can, and especially green bond is important for solving the climate related issues. We are exactly working with the central bank for solving climate challenge in Bangladesh and in Malaysia. 24th June, we have a very, very special seminar on climate change. Definitely it will be in offline, but online you can attend in this way. So this is the way we will improve. We can learn from each other. We can grow. So we try to bring in the maximum partners from developing world and definitely we need more help from developed world. Through this process, we can develop a better ecosystem. Thank you, Mr. Bob, joining today's sessions. Professor Ching, I come to you after Professor Ching. Professor Ching, what you want to add for edge computing?
Okay. Well, one way to understand edge computing is it started from cloud computing. Okay, when the cloud condenses, it becomes fog. Okay, they become fog computing. Okay, so basically they are the same. Okay, they can be as powerful. Edge can be as powerful as a cloud. So there's not, but there is one technical difference. That is, the cloud computing for common data, common technology, common operations, and the edge can be for specialized data, specialized operation. So there is, it just makes things more, proportion to what they are good for. Okay, this makes things, the computing system, more flexible. It's a topology. Okay, so basically this is not even a topology, it's a business innovation sort of, and it's a natural development. And to summarize, edge computing has some features that's characteristic of decentralized data residence. That is a very important point. You can put lots of data into your own edge computing. Okay. And also there's a sameness. If you want to do something which you want to repeat it faithfully, you need the same performance under the same computers then you can control this sameness. Okay, that's very important. So it's basically edge computing functions to extend the cloud. That is another summarized situation. So also is there's a localization with edge. Okay, now people start to use localized place. This is sort of halfway between cloud and the edge. Then finally, some people also mention low latency, real-time performance. So all these are done pretty much being carried out by AWS, Amazon. But Amazon recently got unseated by Microsoft. Okay, so the next company who's going to show us what are the most advanced application in cloud computing and also in edge computing will probably be Microsoft. So this is, in my opinion, this is just a business competition. But in terms of technology, I would say edge computing has been around since 1990s. Okay, it's one of the slowest section of technology. And in my own work, the smartest, in contrast, is the living DNA protein system. So there is, I hope the hardware people would gradually have some kind of innovation, instead of just continue doing the hardware. The hardware, the three characteristics of computing is one is the speed, the second is memory size, the third automation. In my opinion, speed and memory size are not as important as automation, because the five largest technology companies, Apple, Google, Facebook, Amazon, Microsoft, they all depend on automation. Complete automation comes from not from their machines, but from humans, their users. Okay, therefore they become so big. Other nations cannot see this. They're still stuck in the science and technology, and they do not see this power of automation. Unfortunately, there's not a complete automation. So this partial automation brings us into a future complexity crisis. And so we are, our company is sort of waiting for the society to catch up. And I think they are in the process catching up very fast, especially with this lockdown from the pandemic. And when they are locked down, they have to do knowledge. So there's many things which are coming from the lockdown. We're going to have inflation leading to a financial crisis, which would again get, people have to use the solution value to detect overvaluation, which are the causes of financial crisis in the past. And I personally plan to call Jerome Powell, and who's being, renominated for Fed chairman. I have called Alan Greenspan every year since 1984 until the market crashed in 1991. I've worked with Ben Bernanke, and this time I'm going to catch Powell. I think he would be easier to approach. And also, deep learning is approaching our self-generated neural network. Another thing that I think all the people here as friends of this group, in this group, is we have a universal permanent number, which is the only thing that can name DNA. How do you name DNA? Okay, you need to use integers. Also, books are named by international ISBN. And all of us can look into setting this UPN. It has no cost. It's very easy. I'm willing to talk to anyone who's interested. Also, baby boom are getting to be 60 to 75. So health crisis coming. Okay, so many young people who want to go into health, I just give them this information and they immediately know whether it's good or bad. Okay. Finally, I like to make some predictions again. You see, this edge computing is just a business or engineering improvement. And it doesn't really seem to, it's a, you see, all these are engineering things. I took all my degree from MIT, and this Gardner also graduated from MIT. But I have no connection with MIT people now, not a single person, because I have no interest in engineering, which is all based on science, and the science is not advancing much. So I think, I mentioned these 5 companies, they are not into science. You see, they're into automation. Okay, so there is a change of mind people need to be aware of, you see. And also the crisis, the environmental, we had a health crisis. We are still having a health crisis. We're having an environmental crisis. Potentially we'll have a complexity crisis. And we'll have a coming financial crisis. No science can solve any of this crisis. Okay, the health crisis solved by itself, Omicron. Okay, so China and Taiwan, they thought they can conquer Omicron. They can go against nature, but now they're in deep trouble. Okay, they cannot let go. They cannot continue tighten up. So they're in trouble, and they might even lead the world into another crisis. Okay, so these things, we need to have a new type of thinking to go beyond this engineering things. Okay, among all the engineering things, the hardware part is probably the worst, the dumbest, and the least, the slowest. So we need to, and also my friend, he's known as the father of internet, Vint Cerf, predict a digital dark age. So this is a slow thing. It's not going to come right away, but it has been coming gradually. Sometimes we got the lost data. Okay, no matter how many cloud computing or things you invent, eventually all the data will disappear. So Vint called it digital dark age. I'm trying to promote this idea for him, and I also have some interest in this because his solution is just to provide more memory. Okay, so we can save everything, and also at the low cost. My solution is the complete automation. You see, so that everything you do, you can self update, self document. Okay, and one of my proposal to Microsoft was actually it's a complaint. It's not a proposal. It just said that the software developer should pay for all the update cost of the software they develop. Okay, they are, those software people, they're really afraid of this. Okay. And I would probably suggest to Elon Musk, when now he's arguing with Bill Gates, to send this suggestion to Bill Gates. Okay. And I would suggest China and India, with so many people, so much brain power, they will contribute to develop a new complete automated software standard. And that will be beneficial for the human race, and possibly get rid of hardware.
Yes,
We're talking about edge computing.
Thank you,
taking a very bad position.
Yeah.
In any case, thank you for
we
the
have other
opportunity.
speakers, and we have to go for concluding remarks. Professor Bob, So, what interesting thing you have to want to add
Okay.
for today?
Yeah, I think we've drifted very far from the topic, and I'm coming in late, so I don't know how we got here. But can you see me? This is an
Yes.
edge computer. Okay, we've had this kind of computing for many years, and the thing is, the edge of what? Terms like edge computing, cloud computing, fog computing are what marketing people use to make it sound like they know what they're talking about. And once you get past that, they're meaningless terms. We have computing. This is a computer. You can get these for $2, and they're local computing, and that's where computing started. I did do my master's thesis not quite half a century ago on the information utility. So one way to use computers is to share machines, and we had time sharing. But as soon as I could, I got local computing, because computing is just computing. There's hardware used in various places. We have fairly powerful local computers, and this cloud thing is a nice optional service, but you don't want to build any system depending upon it. So I think we need to stop using terms like edge computing, cloud computing, but we need to be specific and just say there's some capabilities we can run locally. We can use services that run remotely, advances of shared systems, whether they're in major service centers, whether they're in your house, is scaling capabilities. So the key thing is we need to recognize we just have computing, and then we have connectivity between the computers. And the real challenge is right now, because we're running the telecommunication infrastructure in 19th century compatibility mode, we have a problem in the middle. So we have to worry a lot about the cost and where computing is. Once we could assume connectivity, we can dynamically adapt to whether or not we get a connection. We can use remote services, but computing has always been local. If you're in the data center, it's local to you there. If it's in your house, it could be something like this. My light bulbs have computers in them. They speak to the light bulbs directly, the switches, it's all local. So we have to stop thinking about, these terms, and just think about, where do you run your programs? Is it tied to specific hardware? Is it able to float? We have technologies for that. Is it able to cooperate with other systems? And anything about where data is, what to collect. That's the whole point, is that's decoupled. In other words, that has nothing to do with edge or cloud. It's basically how system architecture questions. So I think we need to recalibrate the discussion if we're making any progress. And whatever you say, even if you use the term cloud computing, which I do use, or we used to use the term time sharing, when you get serious and have to be specific, you have to stop using those terms and use terms which sort of are more meaningful. So I don't know what else I have to add at this point, especially considering I have only a few minutes, but I can answer any questions.
No, thank you. Thank you. We have to go for the concluding remarks for today's session. Professor David Smith, what's your concluding remarks for today?
Sharif, thank you again. Always a great program to be part of. And, as has been said, what has really driven the need for edge type computing is the need to analyze data in real time. And being at the edge helps you go to real time from near real time that's more to the middle. If you look at the explosion of data, more than 150 zettabytes, which is 150 trillion gigabytes of data, is estimated to be generated by 2025. And this really has pushed the need to look at new ways to do this. Just to recap a couple of final points, though. Why is edge of cloud there? Is because it's low latency that has to work with these sensors and tools, and things like autonomous driving is going to depend on a type of edge of cloud computing. Reduce cost. It really helps you manage your data sovereignty a lot better and use it in ways that we haven't seen before. And as was said by Bob, the home, the intelligence growth of the home and the smart home. I too have the smart light bulbs, the the interface to the smart sensors on my yard watering system, all those type tools. Now, I love my edge of cloud cameras on my front door so I can tell people, can't you read the no soliciting sign that you're ignoring coming up to the house and right in front of you? And oh, by the way, I have you on camera. I'm going to send this in as a complaint. So we're seeing all these types of things where the need for low latency, the need to push processing out to the edge is there. But I agree with Bob. I agree with Marshall. The concept of this has been around for a while. But what was missing in the early things is we tended to put the computers at the edge and didn't pull them into a cohesive federated system looking across it. And that need to go to real time and near real time is what's pushing all these shifts in this type of network architecture, computing fabric architecture there. You know, for many years, the data warehouse was one of the keys in the enterprise. But today we're moving away from data warehouses because the data in is mostly out of date if you try to use it for real-time computing. And that is why we're seeing all these different approaches there. And it's the same thing like we have different ways to service the different type of things we do at our homes, that we do on cars, that we do anywhere else. The key thing to it is use the appropriate tools for what you're trying to accomplish. And cloud and edge computing is a tool to use just like we use cloud computing, just like we use on-premise computing, just like the way we distribute our resources, is to use the tool that works best. And my feeling is we see this dramatic growth in the sensors, the dramatic growth in the need for real time. Edge computing is here to stay for a while until we hit our next evolutions of how we can make processing power, communications power, and the actions we need to take up on using it. So Sharif, thank you again for a great show.
Thank you, Professor David Smith. Professor Kim, what's your concluding remarks for today's session?
I think my conclusion is that there's still a lot more to discuss as we continue to grow. I, like everyone else here, Sharif, thank you so much for having these conversations because we need to bring more awareness of what's going on at this level. Discussing about the safety concerns, about how it's going to grow, the overload that exists. I mean, all of these terms of the technology, they just don't exist in everyday life, and people have no idea what they're really using. I mean, one of my sisters even says, you know, this is just all spooky ghost stuff to me, or, you know, magic. It's and it just happens, and it doesn't just happen. There's a lot of work, a lot of resources put into this. But one of the key things that I want to wrap up with is we just need to be careful. We need to be cautious. We need to build standards now, something that we avoided for many years. But we need to start establishing standards and universal standards. We need to become more universal with our standards so that we can adapt and grow together, because that's what's going to be very important.
Thank you. Thank you. Professor Rob, what's your concluding remarks for today's session?
Well, building on what Kim said, the industry goes through regular changes of focus, analytics, big data, cloud computing, edge computing, fog computing. I appreciate Marshall bringing that up. The terminology is so that the different players in the industry are all on the same page with whatever wave or whatever effort is going on. Because what the industry has discovered is if everybody's talking about something differently, the customer says, "You will wait till you guys figure it out. I'll stop buying." It's an effort to get all the marketing and demand generation efforts in sync, so you actually can generate revenue. Because otherwise, this would just be a mess. In fact, underneath the cover, it's often the industry is kind of a mess because we're constantly arguing about what the next big thing is, or what the current big thing is. In many occasions, depends on where you are. If you're a networking company, it's going to be next. The big thing is networking. If you're a centralized computing company, server company, then of course servers are your thing, and devices and PCs. What you really have to watch here, though, is as we pivot from initiative to initiative, is making things less accurate and creating problems that you're later going to have to fix. And while some of that's good, you create a problem, you have to fix, you're going to generate revenue for the fix as well as revenue for creating the problem. It does create a drag on productivity and the effectiveness of the technology in place. And in fact, looking back at big data, which was a huge industry mistake, the problem was the industry was focused on consuming storage in mass quantities. And these databases got so big they couldn't be analyzed. And ironically, we kind of moved from analytics to big data, which never really sat with me that well. But the end is by focusing on doing something that wasn't what you wanted to accomplish at the end, it creates inefficiency. So big data should have been focused on providing accurate answers at scale, not just collecting the data and talking about the fact that you needed massive amounts of storage, because as I mentioned, and now companies have massive amounts of data that they're so massive and so inconsistent that they're having trouble doing anything with it. Kim also pointed out that data was kind of like the new gold. Gold is still gold, but the fact is a lot of companies, Google being one of the leading examples, Facebook would be another, that make most of their money off marketing data, and the underlying concepts of privacy and personal information security have been largely lost in the process. This is problematic on a number of levels. One of them is the people that are generating the data are not being compensated for the data that they're generating, and that creates an inequality. Some have referred to it as a kind of it's a form of abuse. Particularly if the data is used against the users that are generating it. The first generation, by the way, that has popped up and said that's absolutely unacceptable were the millennials. The surveys at the time indicated millennials were okay with regard to data capture. They were absolutely not okay with the fact that data could be used against them. And it did start a pivot in terms of how information was talked about, and really put a lot more emphasis on the security of the information. But the thing I really, as I say, want to leave everybody with is the fact is we make these pivots, we introduce problems into the system, into the various systems, and we still need to focus on kind of the collateral damage of these efforts. As we move to edge computing, we do have a significant problem with introducing bias into the system, and the parallel efforts we have in the industry is autonomous artificial intelligence. And artificial intelligence, well, just like people, that you feed in garbage, you're going to get garbage out. The difference being that these AIs will make decisions at machine speeds. And so if you corrupt the AI, it is capable of doing damage that could harm our ability to survive on the planet, and that can be problematic. The areas where this is being increasingly being used, as Marshall, I think, pointed out, is in the areas of sustainability. One of the biggest efforts that is currently going on is the effort to create Earth 2. Earth 2 is a metaverse construct that is designed to vastly improve our ability to predict weather, and with the overall focus on finding economical ways to reduce climate change, reduce the impact of whether we can argue whether it's humans or animals or just nature, but the fact of the matter is climate change is doing a tremendous amount of damage. And even if we can just better predict hostile weather coming in, we can do a great deal in terms of preserving lives. If we can model the different remedies, we may be able to find a technological way to mitigate the problem that right now appears to be insurmountable. And that requires a substantial amount of edge computing and sensor data, because you're basically modeling real time the planet as it exists. It's just a massive effort. So as we move through this, it's got to be, as we develop this, you've got to be able to assure that the system isn't compromised, because once again, if you come up with a large scale, world scale method to mitigate climate change using Earth 2, but if Earth 2 becomes biased, it becomes unreliable, then you could actually do massive amounts of harm at scale rather than fixing the problem. So the accuracy of that project will have a direct relationship with the effectiveness of the solution. And the concern, of course, as we talk about edge computing, is introducing enough bias so that end result would not at all be what it is we expect. And that's true of any simulation, our real time. You introduce bias, and that simulation's ability to predict the future goes sideways, and you could actually do harm instead of good. So it is that focus on bias that we definitely need to have as we migrate to edge computing and feeding these large-scale AIs, which will increasingly be controlling our cities, our infrastructure, and eventually our climate. So something to watch out for.
Thank you, Professor Rob. Professor Bob, what's your concluding remarks for today's session?
I'm actually very confused about the topic here, because there's computing as a basic technology, then the particular applications, whether it's environmental modeling, whether collect data, whatever, those are all disparate things. It's not just one hierarchy and one data collection and one answer. So until we have think in terms of systems and architecture, I think we're just going in circles in this conversation. So, yes, they're concerned about climate data, but there isn't just one czar of the climate. There isn't just one thing, and there is a magic blockchain that solves it. So I don't know exactly how to contribute.
Okay, thank you. Professor Ching, what's your concluding remarks for today? Professor Ching.
Yeah, okay. Well, the conclusion is, only when crisis occurs, people will start to look at knowledge. You see, so today, pretty much the world is not changing from my point of view, not changing much. But there is a crisis coming, the financial crisis, 5 to 10 years. 5 years will be really good for real estate industry. Then after that, another 5 years will be going bad. All this has little to do with all this technology, you see. But anyway, we talk about edge computing. We pretty much cover the whole current status of technology. We also move to the forefront. People talking about 2022. They talk about Internet of behaviors and also edge computing. So this seems to be a new thing, but it's not. Edge computing is just as good, as big as cloud computing. So everybody talk about this correct. We need to be flexible. We use all kind of technology for the correct situation. Another thing which is developing that is could be a revolution for computers is microelectronic mechanical system. You see, MEM. That is kind of moving us into another arena and sort of allow us to simulate DNA protein system more closely. And outside that, I think, we need to get into the big pictures. Every topic we talk about, we need to go from the big picture, come down to this single small topic. And show the place where it stands. Especially when we're talking to where you say the developing countries, show them where everything stands instead of specialize the case. In the United States, the situation is somewhat different. I think most of the people talking here are pretty much have a background in the United States. The United States is the new world. okay, where the characteristic of the United States is we're allowed to compete freely. In other words, every one of us should be the best in their field in order to survive well in the United States. So it's sort of different from the developing world where we just want to have some knowledge copying from advanced nations. So the attitude, my feeling is, I'm always thinking about advanced things. I do not think about the basic things. But in this talk, I feel, having talked so many times, I feel that the whole picture is not presented. So it can be somewhat misleading for the developing nations. So we need to everyone sort of give some kind of presentation on the whole picture, and narrow down to this particular issue, which I think this time is okay. Every one of the issue is very advanced. It's really something we all talk about. Yeah.
Thank you, Professor Ting,
Thank you.
for your comments. Mr. Marshall.
Thank you, Sharif. I think it's a very interesting panel that we have today. Again, edge computing is not my expertise, or computing in general, as Bob pointed out. It is all computing, that is true. But I did get involved in computing way back in the 70s, when there was no internet, and a computer that had the power of our cell phones that I'm actually operating on and speaking with you on right now from my iPhone was stored in a large building on a campus. And I was using programming tools such as punch cards to get information and assign that information, get the data in, get the information out, and interpret it. Obviously, we've come a long way since then. And my use of this information, or my use of it, or my requirement for the information, is based upon the real-time data that, from my understanding, is that edge computing provides the real-time information, such as, and the tools or the use case of it is Internet of Things, or an industrial Internet of Things. That's my understanding. I don't know what anyone else's understanding. You can always correct me and educate me. I'm open to that. But my usage of it is in the tools that we're bringing to the table. We have technology, 4 fundamental technologies that we are integrating computing technology, whether you want to call it edge computing or something else or some other terminology. It doesn't matter. We're using it. And that use is in the real world. And that is addressing real world concerns, as both Rob and David and Professor Chin has pointed out. So I think that we need to think about this. I think it's a very important topic that you brought up. The topic is here to help educate the viewers, and also through the World Talent Economy Forum, to get information out into people's minds and mindsets. Whether people agree or disagree is not the issue. The question is, are we talking about relevant topics that will impact people's lives? That's where I'm at. I'm on the edge of the climate crisis. That's my use case. There may be other use cases, as Bob pointed out. The question is, I don't think the definitions are as important as understanding what the information provides and how we get it and how do we prevent it, as Rob pointed out, from being false data. We have enough issues with false data and false information based upon political issues and wars, such as what's going on between Russia and Ukraine. My area of expertise is in turning the environmental issues and using these tools, these computing tools, whether you want to call them edge tool computing or just simply computing tools, to our advantage, so that we can actually improve people's health, lower GHG emissions on the planet, improve soil health so we can grow more food, and at the same time improve energy usage so that we're not causing all these issues that are giving us the problems for the climate crisis. So my takeaway from today's session is I think it's a really good session. I thank you again, Sharif, for bringing us all together. And it's great to hear everybody's different opinion. And I'm with you all the way.
Thank you everyone for joining today's session. Today's session actually really helpful for us. Tomorrow we have debate. Our debate topic: can computer or robot ever displace doctors? We have our two teams. One is governments and oppositions. Tomorrow's government, Professor Rob. Professor David Smith, you will be opposition leader, and it's open debate. It's very open debate, very interesting, and it's become very popular through World Talent Economy Forum. Even you know that in Nikola Tesla Technology Conference, actually we will organize a debate in final day. We will do a debate against AI, against artificial intelligence. So all of our debaters will attend in the debate already. It get a very good promotion, especially in the debating communities. Many experts from Oxford Union, from Cambridge Union, from Harvard Union, from International Oratory Club, it's International Islamic University, and many famous debaters, they will attend in our Nikola Tesla Technology debate. And beside that, as we are taking a lot of practical projects, we have to develop a practical innovation lab. As most of our friends, actually 1, 2, 3, 4, 5, 6, 7, including Professor Edward, all of them actually from North America. I'm really proud of all of our speakers. Even I give example, see how American people, they are smart, how they take the challenge, how they take initiative, how they want to contributing for the developing world. That is important. That is important for World Talent Economy Forum. That is the way uh, uh, the developing nations can learn, because we have major problem uh, in between developed world and developing world. They do not have enough trust, many misconception, many like misunderstanding. But this is my learning last 2 years. North America has, especially USA, has many brilliant mind like you. They want to contribute for the global community, and that is the way how they can help more to World Talent Economy Forum. As our work and our community, our activities is improving, and we are engaging with millions of people, we want to develop our innovation lab. Definitely, USA has a lot of facilities and many things, but we can ensure with the integrations of developed world and developing world. I always say developing world also have different story, different beauties, and we can integrate and we can develop new knowledge. So if we get chance, we are very much open. Any of our friend, they want to work with us, collaborate with us to develop our talent economy innovation lab, we are happy to work with you. Uh, I'm sure our journey will be very interesting and very much practical. Uh, Beside this dialogue, we will change human life. That is our commitment. So thank you all of our speakers to joining today's session. Tomorrow we have debate. Those who want to join in our debate, please join. Trust me, Professor Rob teams and Professor David Smith teams, extraordinary. And if they join in the real parliament, it will be really, really valuable for at least for USA and for the global community. So thank you everyone for joining today's session. See you tomorrow for our interesting debating session. Thank you. Bye bye and take care. Bye bye.